Assalamualaikum. My name is Labib Ahmed. I'm from Section A. My roll number is 180889. So first of all, we take a look on the code. What we're doing the Zumo. So here we have threshold. The first initializing is threshold. We are initializing the threshold and the above line code. So to make sure that our robot is on the line that it check the values of the reluctance sensors and take the readings. So if our sensor is on not on the threshold, not on the line, it will make it possible, or the robot will stop. So then we have the speeds, the turn speed and the speed. We are Let me make it clear. We are uh, adjusting the speed at 300. So at that speed, the sensor can easily check the line, whether it's turning or it's going straight forward. If the speed is much higher, like it's on the 800 or 900, so it's difficult for the sensor, or maybe the robot will cross the line and the sensor didn't check that, and will not check that there will be a left turn or right turn. It will be out of the path and the robot will stop. So it's better to make the speed low. Yes, it's good if we are using the some old battery, or the power of battery is too much down, so we make the speed as much high as possible, because the if we adjust this speed at low power, then the robot even not move, because it's too much low for the robot. Then we are checking the thickness. Here we are using the thickness of 75. So if you are confusing that it's 75 inches, or no, it's not that. How we are selecting the thickness? This thickness is in z units or units. So here is the formula for the thickness, that how much thick that we are using the line. So here we can check that. To here we are use that formula to convert the inches into units. So this is not in inches, because that is too much. Like 75 inches is too much for that. So it's in units. And how we tell that robot how much units? So here is the formula. Then we are moved towards the overshoot, like thickness inches. What is overshoot? As I already told you, that when it reaches to some segment, or it is at the end, or when there is no line, here we have to stop it. Like, or we can say that when the thickness of the line is not that thick, or you say that it's too much thin or too much thick, or there is no line, then that function will work. So here we have Zumo buzzer. Like when we play that, we hear the sound of a buzzer. And then we have motors. Like we are using Zumo motors. We're not using a physical robot, so we don't have to use we don't have to use motors and a motor driver to initialize it. So here we are just using Zumo motors. Like in the simulation, we can see that how the robot moves. By this they can move. Here we have the push button, so make it start or restart. When we push the button, the robot will start working. When I go to the after that code, we will move towards the schematic, and you can see that push button too. Let me have you some visit of that push button. Here you have that push button, Zumo button. Then we have the path. So we are initializing the characters to turn for the turns, and inside character for the path length. Then we are moved toward the chip selections, like how here we use selecting the port 10, or we are connecting the SD card to the 10th IO 10 on the Arduino. Let me verify you the SD card pin. Wait a minute. Here you can see that the IO 10. Here we have the SD card as well as on the Zumo. we both are same because the SD card, we are using SD card to store that path. It's useless for us, like we don't use that. Now we are connecting the serial ports to connect it, like here we are using a, so when you connect the serial port, what should be display in what we should store in the SD card, like serial print initializing SD card. So when we are using this, we can see on the terminal screen that initializing, and in the file we are using, like I'm using a mmc file. So in the mmc file, also the first of all initializing SD card line will be showed. When then it's another for, it's just for the efficiency and that kind of things. So because on the professional level you don't use this you just said that, you put it in and now start the robot. No, we have to first set that whether the SD card is okay or not. Let's suppose if you're using an SD card and it is completely okay, but and it's not okay, and your whole bot is done. But when you put the SD card and you think that okay, SD card is working, now start the boot, and at the end there will be no path, and you only think that the code is not good or there's some fault in the board. You never think about that maybe your SD card is also faulty, because you don't see any command like this that there is no SD card initialize. So initializing field is the main thing. After that, like here you can see, if I make it out, if I, as you can see that drag objects, I think there must be some, oh God, sorry, why is only on the, let me check, maybe no, it will not do. No, you can see that here, you can see if we can put it on, and like if I do that, you can see on the virtual screen that your initialization is failed. So this is very compulsory that whether your SD card is good or not, whether it's working or not working, because if you don't use that type of commands, the whole burden will be on that, and the whole thing you can only imagine is that yes, the robot is not good, or that the apparatus will be apparatus was faulty. No one thinks about the SD card. So let's move forward. First of all, begin the robot SharePoint Zumo. Here we have sensors, status of last status, directions, what direction we should use on that. Then we have a delay button. We have reflectance sensors, motor speed, like how much speed do you selection. First of all, the initializing speed always will be zero. Then you start the push button and robot will start moving. Then we are using the directions, like what direction you are using, and what will be the direction, what will be print on the virtual screen and on the SD card. Then your last status, then above the line sensors. Here you are using the turn left, turn right. What are the turn left commands? They are all the how use their turns. Then you have sounds, then pin modes. Here we have the maze solver, solve the maze. First of all, buzzer play, then button wait for, first of all, when we start, like uh, when we initialize it, you can hear the sound. That wait, I think there must be some fault here. Let's wait. It's initializing, okay. And I show you the, okay. I think there should be some fault. I'm not seeing the changes. Proteus. Just wait. Here we are starting it again, and it's we have our recent project, and then let Okay, our path. Here is my image file. Okay, now you can hear that. Okay, now it's good. So let me show you the is here is a report, and here we have our virtual terminal. As you can see, the initialization is done. If I put out the SD card, you can see there will be no SD card. Let me check you that thing too. Okay, check the circumstances. What's so here we can again hear the buzzer sound, and that's it. Initialization failed. This is all the thing that I want to show you on that. Let's go again on that. Now, as wait for the button directions while count sensors. I think I just discussed that things. Now you can hear the sound of buzzer play, but this is not the sound on. This is the off sound of the buzzer. So for the off sound, we also have to wait to complete the maze. Let's just check this. First of all, we're playing that buzzer play, solve the maze, but now we wait for that. Like here, then everything will be done. The robot will not start. Like you see that until unless you put that. Like you can hear you hear the sound, but the robot will not start until I push that button. So I'm not pushing it now because the code is not still complete. We go on the next. Here we have the sensors. I think that is too much simple. I don't have to explain it. If you have any kind of anything, any kind of trouble, you can just read that comments. Human needs to turn, keep track how much further, count and last status have. Since we're using the sensor, okay, cases, left case, both cases, turn left. While count, the monitor will this loop will monitor the line position until the loop turn complete. Everyone knows when there will be a left turn, it will not it will be a 360-degree turn. If we don't set to it that now it you have to stop or you have to count, you have so here are the right turn case. Here we are using the speed. Of course, if you are turning that, we don't use any actuator to turn it or some stepper motors. We are only using DC motors, so we have to make one of the two motors faster so it can start, it can move or drift and make a turn. Then here we have a case S, like don't do anything. So move toward the SD card. What is saving in that thing? In that, in that, in that. What is saving in that is here we have SD card. Like first of all, left turn, right turn. These things are both on the SD card as well as in the on the virtual screen. You can see both serial prints. They don't have to be explained. So they are just the prints and then the position sensors, and I think it's just done now. We are selecting the speeds. I also explained that how we can move this, how we can make it left turn, how we make it right turn. What's the starting speed? What's the sensors? What's we found on that? on the left sensor. When like everyone knows that on the IR sensor detect the black, and when it detect it, it will give the one value, and it's off. And on the on state, or in the off, and on the on state, it will show zero value. So if we don't see any red line, we don't have any turn. So it means they are zero. When we have one value, it means we are making a left turn or right turn or moving to the straight. And in this, and the straight is for both left and right. Like if we can, we are use we, and like always, the left, the in, like in both cases, in left and right, the forward sensor will be always on. Then we have delay sensors. Here you can see the overshoot line. Yes. Here we have the motor speeds, and I think it's just complete, and you can see that. And these are some push button functions that we are using. Zumo buzzers, Zumo motors. We are using. We are making it on PWM, so we can change that speed as well. Here there's header files. So let's go to the Zumo and first. Oh, wait. Not, no, 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 no. Let's check it. Let's see. Okay, that thing is much odd for me. Here we are, initialization done. So start the zoom. You can see that path is now saving now. Left turn, another left turn. Okay, B. It means we have to make a 360 turn. Straight, then another B, then left turn, another right turn. Okay. Path saved, another left turn. Make another turn. Come on, forward. Right turn, right turn, left turn. Go straight, then left turn, then B. Again, go straight. P. Again, no, left turn, and stop. So as you can see that Zoom work properly. We don't have any issues with that. Let's make some fuss. Because its sensors are not working perfectly. I think it's a start from there now. Okay, I don't have to make things much worse. So here we have the image file. Let's open it. Open with. I think I forgot to install the Notepad C++. So I think I don't. You can see that. We have the path. Left turn, forward, and here we have the complete path we are using. I think I just make it save more than 3 to 4 times. That's why it's showing more than other things. So I think there will be no other questions or anything. Here we have the path in the text file. If anyone need, I will give it to him. Just just told me once. Okay, I think from my side it's done now.